In this video, we're going to discuss how to add and subtract fractions. For our first example, we're going to take a look at 3/5 plus 1/5. Now, before we can add fractions, we have to have a common denominator. So notice that both of these fractions have a denominator of 5. And if you want to know why that might be, you can check out my other video, Fractions, Why Can't We Add Denominators? And that'll give you some insight into that. But for the sake of time, we can't add the denominators. In fact, the denominator will stay the same. So it has to be the same, and it stays the same. And denominator can mean size. So if we're thinking of these as being pieces, they have to have the same size before we can add them, and they stay the same size after we add them. Now we're ready to add the numerators. So 3 plus 1 gives me 4, and that's it. For subtraction, we're going to try the same two fractions and then subtract them. So just like with addition, we have to have the same denominator, and the denominator of my answer will stay the same thing. Now we subtract the numerators. 3 minus 1 gives me 2. And there it is. So to recap, in order to add or subtract fractions, we have to have the same denominator, and we have the same denominator for our answer. Same denominator before, same denominator after. To add, we just add the numerators. 3 plus 1 is 4. And then to subtract, we just subtract the numerators. 3 minus 1 is 2. Now to add fractions that don't have the same denominator, I ask my students to set those problems up vertically. And so what we need to do is we need to change these fractions so that they're still the same amount, but they have the same denominator. And so in order to do that, we are going to multiply these each by a form of 1. The benefit of doing this is that by multiplying by 1, whatever this answer ends up being, it will still be the same amount as my original fractions. But forms of 1 will change it so that way it no longer looks the same. So my end goal here now is I want to get two new fractions where the denominator here and the denominator here are the same amount. Well, that means that I'm going to do 3 times something and get an answer, and 5 times something and get an answer, and that answer has to be the same. Now the easiest way to do this is just to take this denominator and put it up here, take this denominator, put it down there, because 5 times 3 will be the same thing as 3 times 5. So I'm going to do 3 over 3 up here, 5 over 5 down there. Now we're ready to multiply. So 4 times 3 gives me 12, and then 5 times 3 gives me 15, and then 2 times 5 gives me 10, and finally 3 times 5 also gives me 15. So, same denominator here, same denominator there. 12/5 is the same as 12/15 is the same as 4/5, and 10/15 is the same as 2/3. So this problem right here, if I go ahead and add it up, will be the same as this problem right here. Now that we have the same denominator, we can go ahead and add. So 12 plus 10 gives me 22. And if these pieces were 15ths and these pieces were 15ths, then my 22 altogether are still 15ths. To finish off this fraction, we need to think Thanksgiving. So if I have 22 slices of pie and it takes 15 to make a full pie, well then I can make one full pie, but there will be 7 15ths left over. And that's my answer. To subtract two fractions with different denominators, we're going to go through once again the exact same steps. So once again, we're going to take each fraction, multiply it by a form of 1, and our end goal is to have the same denominators. Well, just like last time, 5 times 3 is 15, and 3 times 5 is 15. So that is the easiest and quickest way to find a common denominator. So both of these will be 15s. 3 times 5 is 15, 5 times 3 is 15. Now let's multiply the numerators. 4 times 3 gives me a 12, and then 2 times 5 gives me 10. And here's where the only difference with subtraction comes in. Instead of adding, now we subtract. So 12 pieces minus 10 pieces gives me 2 pieces, and those pieces are still 15ths. One last note about adding and subtracting fractions. Earlier we discussed the fact that the easiest way to find a common denominator is just to multiply your denominators together. But it's not always the best. Easiest, yes. Best, not always. So we're going to do this problem twice real quick. So first I'm going to do this problem where I'm just going to switch the denominators. So 3 over 3 up top, 6 over 6 on bottom, and then we multiply. So 3 times 5 gives me 15, 3 times 6 gives me 18. 1 times 6 gives me 6, 3 times 6 gives me 18. So again, we notice it worked. We got 18 and 18. And now we can subtract. 15 minus 6 is 9, and those are 18ths, which of course we would need to reduce. However, let's take a look at the other problem. Now notice that my two denominators are 6 and 3. If we think about it, we should be able to come up with several common denominators that we can get to by multiplying that are less than 18. For example, 6 times 2 would be 12, and 3 times 4 would be 12. So I could turn both of these into twelfths. Or even easier yet, 6 times 1 would be 6, and 3 times 2 would also be 6. So I can turn these both into sixths. So up top, I would need 6 times something gives me 6. Well, that's obviously 1. So that fraction's not going to change really at all. 5/6 will still be 5/6. And then down here, I need 6 times something gives, or excuse me, 3 times something gives me 6, which would be 2. So this guy would be 2 over 2. And now we multiply 1 times 2 is 2. Now we've got smaller numbers. 5 minus 2 gives me 3, and these guys are sixths. And if we do some quick reducing, 9/18ths, 3/6 will both reduce down to 1/2. However, it's a little bit easier to reduce 3/6 than 9/18ths. So what we see here is multiplying the denominators together will always give you a common denominator, but it does not always give you the smallest common denominator.